All right, so this is objective 3.1e. 3.1e. And today our focus is probably, I should make the screen bigger. Yes, I should. So let's do that. Which gets my 3.1e messed up, but that's okay. You do have to make some corrections because I apologize for being unprofessional. I printed out the wrong copy of the notes. I didn't print it out with my revisions. So our topic for today is applications of inequalities, linear, compound, quadratic, and rational. I think that your notes just say linear and compound, so if you could add those two terms. And I actually did one other thing. I printed out my note page, my personal note page that I use as a guideline, which is why you're not having to fill in your objective and all of that. I am off my game this morning. All right, so our instructional objective is to develop inequalities to represent real-world situations and use them to solve problems. Look, here's the thing. When it comes to word problems, it's not your ability to do the math, because you have the ability to do the math. It's always a barrier from translating the words into the math. So every time I teach you skills, right? When we did linear equations, after we did linear equations, we put it in application. We solved real world problems, and they were hard. Do you remember those? They were hard. Remember we were doing mixing solutions and all that? It was hard. And then after we did quadratics, we did word problems again. And now we've done inequalities. So we're going back to applying them to real life. And so here's the thing. Like I said, you know how to do the math. You have the skill. It's like when you go to take the ACT test. In a math and now class, by the time you take the ACT as a junior, you know 98% of that math. You know how to do it. That's not your barrier. The barrier is translating the words into the math. Okay? So that's what we're going to practice some more today. There's one more typo on your notes. It says in your note, strategy for modeling with equations. We're not doing equations today. We're doing inequalities. So, cross out the word equations and change it to inequalities, please. All right. So here we go. Our process. It doesn't really change. Analyze the problem. Read. Read, read, read until you understand. Look for key words. They're so helpful. Draw a diagram if you have to. Or create a table if you need to. Some of these problems are so basic, it's just, should I choose greater than or less than? That's really the only decision that you have to make. All right, then we're going to pick a variable, represent the quantity being found. What are we looking for? And then we'll find a way to express the quantity in two different ways, whether we write it in a sentence or as a total. We'll write it as a sum or as a product, whatever. Then we're going to form an inequality indicating that the two quantities from step 3 are greater than or less than. It could have equal signs in them as well. That's not important. Just understanding that one side will be more than the other. And then we solve it. Because that's the skill we've just been practicing, solving inequalities. Just solving. Okay, check your solution. Does it make sense? If not, adjust your plan. Try again. Sometimes I like it when your answer doesn't make sense and you think about it, because that's when the learning, the major learning and growth in your brain occurs. When you make a mistake and you realize you've made a mistake, and then you sit and you think about, how do I fix that? That's when learning happens in math. Then, of course, you answer the question. And I want that question in complete sentences today, and I'm going to explain why in a little bit. All right, so here's what we're going to do. First, I would like for you to write in this empty space right here the word no. and the word not, because they're really powerful little tiny words. Not very big, but they're powerful. So when I tell you for homework, the truth coming at you right now, for homework, that I do not want you to do homework for more than 45 minutes, or do work for no more than 45 minutes. What am I telling you? I want you to do it for less than or exactly 45 minutes. I don't want you to go to 45 minutes and 1 second. If I say no more than, I don't want you to do more than. I want you to do less than. So the no is the key word to tell you don't pick greater than. If I tell you no more than, you do less than. Okay? So that's really important terminology there. Okay? So that means do the opposite. Opuesto. Opposite. Okay? All these little skills that we're adding to our toolbox are going to help us to solve these problems. Okay, I'm going to clear that out and scooch my page up a little bit. Here we go. The key words. I am going to require you to use them when you write your answers. Okay? And they also are helpful when you're deciding, should I be using a greater than? Should I be using a less than? Okay? Translating the words into math to help you solve the problem. All right, so keywords for less than. They're very much self-explanatory. Less than means less than. Below means less than. Fewer than means less than. Up to could mean less than. Okay? It's not the less thans and the greater thans that are the problem. It's the less than or equal to's and the greater than or equal to. So let's take a look at this first one. It says, for less than or equal to, you will see words like no more than. Put a box around that no. I just told you I wanted you to focus on it. No more than means I don't want more than. I want the other two options, less than or equal to. Another term or phrase that means you're going to use less than or equal to is at most. At most. And see, that word most makes you think greatest, right? Right? Does most to you mean greatest? But if it's at most, if you can weigh at most 200 pounds to ride this ride, you better not weigh more than that, right? You better be less than that or equal to that. Maximum is another term that tells you that you're looking for things that are less than or equal to. Not above. Well, the opposite of that is, I don't want above, I want below, or I want even. Exactly. Does not exceed. There it is again. The opposite of exceeding. Whatever that word is. I looked up antonyms. I couldn't find a single word. And then top limit. If it's the top, then everything else is below or less than. Okay. So there's those key words. Then we have greater than, where we have the terms more, greater than, more than, greater than. That's obvious. Exceeds or is exceeding or is above. Now let's go to greater than, and there is a word missing here. Let's see if you can find it. So we have no less than or no fewer than, which means I want the opposite of less than, right? Which is greater than or equal to. At least, which is the opposite of at most. Yeah? Minimum, which is the opposite of maximum. What am I missing? I have not above. Not below. And then I also have bottom limit, whatever that limit is, like the minimum weight or the minimum height to ride this ride. Okay. And I couldn't find one. Like I said, I couldn't find an antonym for exceed. Anyway, so those are the key phrases, and you will be using them, as I said. So we're going to switch over to this problem right here. Oops, let me erase that. No, erase. This problem, and let me erase that too. Okay, erase. Come on. Okay, so I'm going to have you read, one of you read this problem, and my instruction to all of you is this: look for the key word that helps me determine if I want greater than or less than, greater than or equal to, less than or equal to. Look for the key phrase or key word. Okay, Gage, read. Awesome. Thank you. So we read it. Maybe you need to read it a couple times. But I want to know if anybody identified the key word or phrase. Richie, what you got? The weight limit. Okay, well, I saw limit in less than or equal to and greater than or equal to. So what kind of limit is this, Richie? A top limit or a bottom limit? A top limit. Did you guys agree that we're looking for the top limit, which means that we are looking for, I'm going to write this down, the weight limit to be, top limit is what? Less than or equal to, greater than or equal to? Less than or equal to what? The top limit is what? 65,000. All right. So now I know that that's what I'm looking for. The less than or equal to 65,000, right? Because we don't want the truck to go on it if it weighs 80,000, right? Because it'll maybe crash into the water or the gorge or whatever the bridge is going across. So I know we have a capacity of 65,000 pounds. Capacity is another word that's a weight limit. Okay. All right. So let's define our variable. Let's let x equal something. What are we looking for? The amount of what? Cargo weight? So we're going to let x represent the weight of the cargo weight. So we've defined our variable, which is step 2. Okay. So we know that when this truck right here and its cargo right here, when they go over the bridge, they have to be less than or equal to 65,000, right? Of course, my 65,000's over there, and my weight is over here. Do you see what I did there with my picture? I should probably scooch it around, but it is what it is. Let's take some information from how much does the cab of the truck or the tractor weigh? 20,000 pounds. How about the empty trailer? 12,000. So if the truck's empty and it goes across, how much does it weigh? 32,000. And we are saying that the weight is going to be represented by X pounds. We don't know. This isn't a particularly difficult problem. The weight of an empty truck plus its cargo must be less than or equal to 65,000. Of course, you can write that the other way. You can do 32,000 plus X is less than or equal to 65,000. I'm just matching my picture here. So, to solve that, of course, all we need to do now is subtract 32,000. So we get 33,000 And we probably should rearrange that to say X, or the weight, has to be less than or equal to 33,000. Change it so that the X is first, because that's the way we like to do that. Okay. So now I ask myself, since I've solved the problem, which I think is step 5, and step 6, does my answer make sense? So if I pick a weight that is less than 33,000, pick one. 30,000. How much is my truck and my cargo? Is that okay for crossing the bridge? Yeah, it totally makes sense. So now we have to go about answering the question. So if I were to write the answer to my question, I would ask you to write it in a complete sentence. And I'm also going to challenge you to use one of the phrases in the less than or equal to column. So everybody's going to do that right now. You're going to write your solution. Make sure you focus on the cargo weight, because that's what you're trying to figure out. All right, so who's got an answer, solution that you want to share? I want to hear what you come up with. Go, Dama. So, the truck can carry no more than 33,000 pounds of cargo and still cross the bridge. Beautiful. Beautiful. Did anybody do a different one? I know you did. Austin. Beautiful. 33,000 or less. I love it. Okay. So that's your challenge. Here's what I'm looking for. For you to develop your vocabulary through writing by using that terminology and just making it a natural part of how you speak about inequalities. It will make things easier in the long run. The more you use vocabulary, the more you own it. Yes? Right? How many of you used the word persevere before this year? A few of you. Yeah, how many of you know exactly what I'm talking about when I tell you to persevere? Yeah, exactly. Why? Because it's become part of our vocabulary. All right, your job is now to do this next problem on your own. Okay? And I'm going to ask you for your answer here momentarily. So, pausing this. All right, so who wants to tell us what solution? What is the minimum amount of hours that she will have to work? Austin, 54 hours. So, you subtracted 31. You got 850 times the number of hours is greater than or equal to 457. And you divided by 850 and you got x is equal to 53.7 or something like that. Hours. And so your answer to the question is, Erica, say it one more time. Would have to work at least, I like it, you use the terminology, 54 hours in order to buy the shoes. 53.7 hours, right? But 54 hours, you can round it up, makes total sense. Very good, right? Using that terminology. Minimum means at least, right? It's the minimum, it's the least. Nice job. Okay, anybody need an explanation or clarification? Okay, yes. You could say 53 hours, I think it's 42 minutes or something like that, but the question doesn't say, the question says how many hours. It doesn't really specify minutes. Of course, I like the precision, but this is an acceptable answer to me. At least she could work 80 hours, yeah? And afford the shoes. Right? So the minimum would be 53.7 hours. Okay. So here we go. The next problem is about compound inequalities. And in your note page, there's a little space next to the word compound inequalities. I would like you to put the keywords for these. I didn't put them in there. The keywords are between and range. And they're going to, for purposes today, create double inequalities. So we're looking at the something is less than x is less than something. The double inequalities. Okay? All right. So those are our keywords. And so let's have you read this problem. Mason, would you read? Awesome. Keywords. Who's got them? Between and range. Both of them are there. That's a double hint that you need to be using a compound inequality. You want a range of heights. So you want to know, can you be like 5'4" to 5'9" in that range? Or 3'2" to 8'9"? Huh. These are in centimeters, so that wouldn't work for this. But that's what it's asking for, a range. So what's the bottom of the range and what's the top of the range? All right, so let's let x represent. What are we looking for, people? The height. I think we should say the possible heights of a skier. So the possible heights of a skier. Because there's more than one height here, right? It's a range of heights. So we're going to let x represent the heights of a skier. And since we see the words between, okay, the skis are between, what's the smallest measurement? Because that'll be the furthest to the left, the bottom of the range, 150 centimeters. And the largest are 220. And your height has to be somewhere between those two numbers. Well, between the criteria of those two numbers. So when we do these, folks, we're doing less than. When we do compound inequalities, it's always the left is the smallest, the right is the biggest, and the thing in the middle should fit in the middle. But can I be exactly the shortest height? Yes. So I'm going to need an equal to sign because I can be exactly the shortest height possible. I can also be exactly the tallest height possible. So we would include equal signs in this problem here. And there you see I've developed with my little pictures there, my little diagram, how it set this problem up. So here's my height, right? But there's a criteria in this sentence. They recommend that the skis be 1.25 centimeters longer than your height. So what would I do with my height? Plus 1.25 centimeters. And of course, I'm being really precise here by putting the parentheses around it and tagging it with centimeters. You don't need that to solve this problem. All right, so we're going to solve the problem. 150 less than or equal to x plus 125 less than or equal to 220. Compound inequality. It's a double inequality. With the height being between. Yes? Yes? So we would subtract 125 from all sections. 1.25. 1.25. Of course, we'll do that with a calculator. I believe that's 148.75. Less than or equal to x, less than or equal to 218.75. Check my math. Okay. So we've done the math. Does our answer make sense? Pick a number between these. 150? So if I do this, it's 150 less than or equal to 151.25 less than or equal to 220. Yeah, totally makes sense. So I believe we've found a good answer. So now we have to answer the question using the vocabulary. Now, there's a couple ways you can write it. I've had some people in the last couple periods get really fancy with their answer to this question. So you can get as fancy as you like. I'll give you 30 seconds to come up with a beautiful sentence using the phraseology that's important. Go. Come on, who's got one? Go. So the range for the recommended height must be between 148.75 centimeters and 218.75 centimeters. Great. Perfect. Did anybody get fancier than that? So you used a minimum, but no more than. Beautiful. Or at least 148.75 and at most 200. You see, I can get really fancy with that, right? Okay, good job. Right, last one is this one on the back. And you have to do it by yourself. But I will provide you with a little bit of information. So we're going to read it, and then you're going to do it. It says the perimeter of an equilateral triangle. Equilateral being a really important word right there, and perimeter being a really important word right there, is to be between 95 and 105 inches. Find the range of possible lengths of one side of the triangle. I think my sentence is a little more clear than yours, but that's what I'm asking for. So what does equilateral mean? Sides are equal. Yeah, equa is equal. Lateral means sides. That's what the word lateral means. Lateral means sides. So if I want you to point to your lats, you're pointing at your sides, your laterals. Okay? So the perimeter of an equilateral triangle, what is the most efficient formula for that? It's an equilateral triangle. How many sides does it have? And you're going to multiply that times x. That's the perimeter of an equilateral triangle. All right. So there you go. I want to know, what is the length? What are the possible lengths of one side? Off you go. So your solution. We've done the math. Set up our inequality, our compound inequality, because our key word was range. Yes? Range of possible lengths. So who's got an answer? Go. Correct, but how are you going to write that in a sentence? So the range of the, I'm going to put side length. Is minimum 31 2/3 inches, and at most, getting fancy, 35 inches. You could also say the length of the side is between 31 2/3 and 35 inches and be really just basic there. Okay?